All right, welcome to School Facilities and Operations Podcast. I'm Burke Jones. I'm the host, and every week we bring you a trade partner that shares their knowledge with us, things that as facilities professionals we have to deal with every day in our buildings, and we pick their brains and try to bring you some great knowledge. And then the other type of show we have is we interview a facility professional working in the school system. So today, though, we are joined by a trade partner. Steve Mankins from BCS is here. So, welcome, Steve.
Hey, thanks for having me.
Sure. So, we're going to dive into the world of controls. But first, Steve, just give us a little background on your career and kind of how you got to this point, and then something about you that we can't read on LinkedIn.
Okay. Um, well, my career started as a facility person. So I was a maintenance guy, um, then stepped up into a chief engineer role. So I started in the maintenance industry. Took care of a couple of buildings in downtown Wichita, Kansas, that high-rise buildings. Learned a lot, had a lot of people teach me things. Um, Young kid, 18 years old, just starting out, and and then all of a sudden it started into some education and learning about the building maintenance side of the world. And finally, one day, um, the company I work for now, they said, "Hey, you seem to really enjoy this. Why don't you come to work for us?" And it took me a couple of years to really get that feeling to go make that change, because I was very comfortable where I was at with what I was doing. Anyhow, went off into the contracting world, and I have been over here um, since 1989, so a long time. Um, got lucky, found what I really enjoyed, and um, it's been good to me. So,
Fantastic.
um,
So, give us a little
some,
tidbit of some other part of your life.
so there. If you looked at my profile on LinkedIn or any of those places, you'd see some things about traveling and stuff like that. But probably that would surprise some people would be that I absolutely love and enjoy going to the opera. And
That is
there,
surprising.
yep. So people that know me, they know I like classical music, and that's always on my playing in the truck whenever I'm driving places. But you, so I'll give a pitch out to the Santa Fe Opera that if you ever go there and you want to go to an opera, oh my goodness, go there. So you
In,
can
in Santa Fe, New Mexico,
in Santa
or
Fe, New Mexico. Yeah,
okay.
yeah. So you can tailgate just like you're at a football game. Um, but instead of barbecue and beer, it's more of a wine and a tablecloth. but
That is
but
super cool.
you can go very comfortable. So anyhow, I
Santa
love
Fe,
going to the
there this summer. It's a very cool town.
yep
Um, Fantastic place to vacation.
yep, I agree.
So let's dive into controls. You know, I so in my previous 26 years, I was an architect, and I had lots of controls conversations with clients that essentially amounted to, let's talk about how you're going to manage your HVAC system with DDC controls, and do you want it all on a computer or do you want thermostats? I mean,
Yeah.
and from an architectural perspective, I thought it was all pretty simple. And then I take this job and I've got 15 buildings that are all on building controls for HVAC and some lighting and different things. And I discovered very quickly, like, this is an entirely different world than I imagined it was. So I guess maybe take us through a little bit of the history. Like, what did controls used to be? What are they now? And then we'll kind of go from there.
Oh yeah, perfect. The history of controls is amazing. So for a long time, it was all pneumatic controls, and pneumatics has an air compressor at the heart of it, and you're pushing a little air out into these copper or poly tubes, and you've got devices and sensors and thermostats and all these controls, but they were all controlled with pneumatic air. And and that was, if we go way back, the old D-ring thermostats. I wish I had one to hold up here. The old D-ring thermostats are still out there today functioning, and we can buy them from the different manufacturers. So it's not like it's gone, but it's out there. Anyhow, the
Right.
so that when I started, that's what I grew up on, was the pneumatics. So I could go around anywhere I wanted to with a squeeze bulb and a couple of fittings, and I could hook up to an actuator and I could move that actuator. And it was so easy. If I needed to get cooling, man, I could do it. Then I could go fix the problem. The so in the 80s, when we started to have the introduction of the computers, and we're going away from mainframes and doing the personal computers, that's when all of a sudden things automation started to show up, and nobody trusted it in the early days. I think of around the office, we were so excited that we automated the coffee pot. and, and we could turn on a relay, which put power to the coffee pot. And when we came into the office, we had our hot coffee. And today, you know how easy it is to do that today. But I mean, that was big stuff back in the middle 80s.
Yeah. Now you just hook a coffee pot up to your Alexa and it just happens.
Exactly. So
Yeah.
yeah, the technology, just where it's going, is amazing. But back in the old days, the pneumatics were trusted. They did a great job. You had big high dollar service agreements on them to maintain them, and you had to do that, or they just wouldn't work for you. Computers came around, controls came around, and so we started to add these electronic controls, and facility people, like I said, didn't trust them. So we had bailout switches on everything. And I can remember a customer in particular that on pretty much all of them, you just had to have this bailout switch. If my electronics go down, or that computer burns up or doesn't work, I got to be able to go over there and flip a switch and go back to the stuff I trust. And
Right.
and and so the electronics were working, the control systems were working, and all of a sudden there was a power bump, and you set it up automatically to switch back over to the pneumatics. And now the
Uh,
pneumatics didn't work because you hadn't been calibrating them and testing them and servicing them, and so it was like, that broke, and that stuff isn't working because I hadn't been calibrated. So then finally, it probably took, I'm going to say, 6-7 years, maybe a little bit longer, to get people to not put in the bailout switches, and then we started taking them all out. Um,
nice.
but so anyhow, so we started down this path of the electronic controls, and I can take into a program lines, and I can show you a receiver controller was a pneumatic device that had all these pneumatic inputs that came into it, and it controlled a hot water converter. Well, you had to tune that and tweak it and adjust it and set the throttling range and all these things. And then all of a sudden you had one program line that you could type in, and it would replace that $400 receiver controller. And now
Right.
it's like, that's cool stuff right there. And now that we've got everybody's now has it, some flavor or another.
Right.
So much more accepted. Back in the old days, we thought that was going to eliminate staff or cut down facility staff, and people sold it like that. But the reality was that you still had to go out and maintain it, and it never eliminated anybody, and in some cases created opportunities for people. So
Well, I think it really has. I mean, you have staff now that is, I'll say, I don't know if you use the term gray collar or what, but they're like computer technicians maintaining equipment.
yeah,
Um, So it's a fascinating thing how the profession has evolved because of it.
Oh yeah, totally. I a good mechanic that knows the basics of air conditioning and refrigeration and heating, boiler and chiller operation. I can take a good mechanic that knows that, and if he wants to learn controls, wow, they make the perfect technician.
Yeah.
They because they understand what they're programming versus a programmer, a computer guy writing some code that is perfect, but he has no idea what he's turning on or off out there.
Right.
So,
Exactly.
so
So I guess what kind of things, I mean, I'm still learning all this, but I mean, I understand we can control the temperature of the space,
mhm.
but in some systems goes beyond just the temperature. It's turning fans on or bringing fresh air in, all of that kind of stuff. So, um, is that primarily what people are using them for today?
um, uh, yes, to just be brutally honest about it, yes. They look at a high end control system as a time clock. You can go out and buy a time clock that's got a rotary dial that you put the little fingers on, and you can turn a piece of equipment on and off. That's what we used to do.
Right.
And I can buy that for a couple $100. A new control system. I mean, as a facility director, that's a whole nother trade and expense all on its own. You can spend
Right.
thousands of dollars, and so yes, it is a time clock. But if when used properly, scheduling is your single biggest energy savings thing you can do.
Right.
But you turn around and you start operating equipment efficiently, and you start putting things in like optimum start stop, time optimization programming that says, hey, my outside temperature is this and my inside temperature is this. It's only going to take 30 minutes to get up to temp. And so I'm going to delay my on time. So you can make it smarter. That's where the computer side adds that is it adds that smarts that looks at maybe a year ago what was going on, and then looks at the previous 7 days and calculates when to start things properly.
Hmm.
Some of the new energy codes, single zone VAV, we programmed some of that, 10, 15 years ago. And now it's written, ASHRAE. There's actually ASHRAE guidelines that you have to use single zone VAV, or you should use single zone VAV, and that's where your equipment modulates to maintain only what's needed in the space. So if I need a compressor running, and I got a 10-ton compressor, but I only have a 5-ton load, I could modulate that stuff to maintain a 5-ton load. And now I get the savings associated with that. So just controlling temperature, staging things on and off, that's where we were 15 years ago.
Right.
Today, we're doing all this modulation and this anticipation and this additional control to be more energy efficient. So the then I think of things like we're controlling temperature. That's what everybody thinks of first. But you've got a sump pump in every facility, and by putting a simple sensor in there to know the level of that sump and trend it and monitor it, you can literally watch the performance of your ejector pumps and know if something's failing. So the things that we're doing today are a lot more analytical, um, and predictive on failures and being ahead of the curve, so that if a compressor fails in a rooftop unit, the tenants are going to know it. But you can have the control system go, hey, I turned on that compressor. My supply air temp didn't get below 60 or say 55 degrees. I can send an alarm and let facilities guys know that unit's not performing. And now all of a sudden it's your extra set of hands out there watching your equipment. Um, a temperature sensor in a freezer. I think in schools, there's the kitchens, and you've
Right.
got thousands of dollars worth of produce or frozen goods in a refrigerator or freezer, and you go home on Friday night and you come back Monday morning and the ice cream is melted and run out the freezer door, and it's like, oh my goodness. And then all of a sudden we're scrambling, and $40,000 later you fill the freezer back up.
Right.
Well, a $20 temp sensor and a system that can tell you that didn't work, think how much money that can save you. So
Right.
it's just,
What
those are the
what are
things.
those what do the alarms look like? Are they text messages? Are they emails? Do they have to typically pull up the interface to see them, or what's it look like on that end from the user
Yeah.
side?
So you can get either an email or a text. Used to be we would do an analog call. Since things have gone digital so much, we've kind of gone away from the voice calling type devices. But now I can get on my phone. I get alarms from customers, and it's instantaneous from when that's actually happening. And then I can take my phone, log into the system, see oh, I need to call somebody out, or I need to do something, I need to go in. It's a email or a text are typically the two ways today that people get those messages. And
Okay.
so yeah.
So before we move on to like what the future looks like, I got a very specific question. Talk to me about set points where in systems where you can heat and cool, like not at the same time, but you know what I mean. They can switch
Yeah.
back and forth from heating to cooling. So I've run into situations where the set points are too close together or something. Can you explain to me like what that looks like? And then what are most institutions using for set points? Like what's the temperature range that they're using for cooling and for heating?
Uh-huh. Oh yeah. So the set point range, by default, I can tell you is default in a lot of systems is like 70 for cooling, or sorry, 70 for heating and 74 for cooling. Um,
Okay.
as with our customers, depending on the customer, you go to a hospital customer and now a patient room, they can have infinite control. Um,
Right.
you know, Patient satisfaction is huge. You come to a school facility, now it's kind of like, what is the proper range that we can do our best learning? And
Right.
by all means, you don't want the little kindergartners with blue lips, and that, we can't do that kind of stuff.
No, we don't want that.
Nope, that gets the parents on us, and that's not a pretty day. Um,
Right.
the so if let's say that I'm gonna answer this kind of in a indirect way. Gas prices. When gas prices skyrocket, the first thing we do is we lower that heating set point.
Right.
Back in the Jimmy Carter days, as a building operator, they set out some national energy guidelines back then after all the energy stuff of the 70s and early 80s. And we operated buildings back then 68 to 78. And you locked all your thermostats in, and then you got a plaque to hang in the lobby of the building that said, hey, we're meeting these guidelines. So our set points will adjust as our conditions around us will adjust. Okay.
Right.
But I think anytime, if you can, in a school district, upper management, everything from the superintendent to the principals, everybody's got to be on board on how we're going to save energy. And by locking you in at a 70 degree or a 74 degree temperature, and I see districts do 70, 72, some as low as 68 on the heating side. I see some do, 72 to 74 to 76 or 8 on the cooling side. It just, Everybody has a little different feel for that. 70 to 74 is a good range.
Right.
Most people are comfortable in that range. If you look at all the documents out there, 72 degrees and 50% humidity is the perfect environment.
Right.
But we don't want to go between that flipping back and forth, heating to cooling. You like a nice consistent temperature across the building. As I think as the kids go from classroom to classroom to classroom, if there's one teacher that sets it to 78, another teacher sets it to 68, the teachers aren't the ones that are suffering from that, the kids do. So if you
Right.
can, that consistent temperature provides, I think, a better learning environment. Um, the so I kind of beat around the bush on that. I didn't really
No,
answer your question,
and I
but
think that's the answer. I think you have
yeah,
to decide and then get buy-in from every level of the district that that's what we're going to be.
yeah.
Um, so is there an issue if the heat and cool set points are too close together or something?
You can get, yes, yeah, you can get some bouncing back and forth because if you think of a heat exchanger, like on our homes, we fire up the heat and then the burner shuts off and the fan continues to run and it puts that extra residual heat from the heat exchanger in the space and warms it up that extra degree. That's called heat anticipation on a typical thermostat.
Right.
Cooling does the same thing. And so if you've got a system that you've got to let it equalize out a little bit. You've got to don't let it if you've got a, let's say we've got more heat than we need in a space and we turn the heat on, then it's going to get to temperature and shut off, overshoot the temperature, and then fire up the cooling immediately. And that cycling back and forth is not efficient at all.
Yeah.
So yes, no, you don't want them too close together. Um,
Okay.
I would give this. These are mechanical systems we're controlling, and they're not instantaneous all the time. They may be working with chilled water or hot water, which is a great efficient medium, but it takes a few minutes for those things to respond. So
Right.
broaden out that range between that switch from heat to cool. So
Yeah.
if you're doing at 70 to 74, that's probably fine. So
Yeah.
yeah,
Yeah.
give yourself a little range there.
Yeah. Well, I think we all experience at our house too. I have these conversations with my kids. It's like, it's hot in here. I'm like, well, the air conditioning is about to kick on. Like
Yep.
there's a rain. So yeah, they want to go over and hammer it down. And I'm like, just wait 5 minutes and it'll probably be cool. But,
Yep. Yep.
um, and then when you're talking about big buildings, it even probably responds slower than that. So,
Oh yeah. Yeah. I know that most control systems have a not only a temperature range from the heating point from cool to heat or heat to cool, but they also have a built-in time delay. So they're smart enough to go, hey, I'm going to wait at least 10 minutes before it makes that switch.
right.
So,
Yeah,
so,
that's cool.
but
So one of the things, I mean, I'm looking at been doing a lot of research like on work order or well, I forget what the term is, CMMS systems
uh-huh.
and a lot of them are selling this integration with facility scheduling. So um, if we have a building that's after hours, there's a music program in there tonight. That system can tie into our control system and automatically condition the space during that.
Yeah.
I mean, that's probably the next evolution, but do you see people moving that way? What's even beyond that? Like, what kind of things are you seeing coming down the pike?
So that tenant occupant control like that has been around for years. Um, so it's been a function in everything from the hospitality industry to office buildings and and schools today. They're public buildings anymore. Um,
Right.
yeah, so they made the track or the gym may be open to the parents and the community, till 10 o'clock at night. And so yes, we see that. Also have seen things like when somebody requests that to be turned on, and let's say it's an outside entity, and let's say it's not a community thing, but it's an outside entity, and you're renting that space, you can
Mhm.
actually attach a dollar amount to that rental. When I fire up that piece of equipment, depending on what it is, it will have a dollar amount attached to it. Did I have to start a great big, 400-ton chiller to handle that gymnasium? Um, so actually written code that would, when a tenant in an office building pressed their override button, it turned it on for 2 hours. It turned on the rooftop equipment. And now there was a dollar amount attached to that. And now tenant number two presses their button and it set them up for 2 hours, but it took out and it said, okay, for 15 minutes, tenant one gets the full bill. For the next hour and 45 minutes, they split it. And the last 15 minutes, tenant two gets the full part of that. So you can get crazy with how to do that. But it's been around for quite a while. I see that in schools. I don't see many schools use it, um, only because their buildings, the activities go on all
Right.
night long, whether it's a church organization using it or a scout group or bitty basketball or whatever. Your buildings are you're 24/7, 365 anymore.
Just about.
Yeah. So and but these buildings are gorgeous. They're great buildings and ultimately we the taxpayers pay that stuff, and why
Absolutely.
not open them up and be able to use them like that. So no, I commend all of you guys for doing that and working with making it available. So no,
Yeah.
that's very
I know. I
cool.
mean, we just handle that kind of thing manually. So if someone needs the auditorium, we get a work order and we make sure it's conditioned.
Yep.
Um, I
And I
suppose
think
I'm
that's
not
what
the
most do.
pneumatic. What?
I think that's what most do.
Yeah, and I'm probably like the pneumatic back, thinking about the pneumatic guys being uncertain of the new computer stuff. In some ways, I'm like, I'm not sure I trust this automated system. Then I'm going to get a phone call and 400 people are going to be hot.
Yep. Yep. Oh yeah. Yep. I I there I think of the Sedgwick County 4-H building out by the zoo. And
Right.
have you ever rented that space?
No.
If you rent their space, there's one big room, and it has partitions that you can rent a third of it or a half of it or whatever. The thermostats say press and hold this override button. And so there's instructions to turn the HVAC equipment on, and which is cool, because not everybody will be savvy on how to start up a system, and uh,
Right.
and so they put a little plaque up there, but it says how to turn things on. In your system, all of the thermostats have an override button on them, and if you program an override time in them, then if somebody's coming into a basketball game, they can press that button and it will turn it on for an hour or 2 hours or whatever you program in there.
Right.
So it could be somewhat automated, but it's once they get there, they can do it. So
Right. Right. Yeah, I think we try to usually have it there already. Like we
sure,
want to
sure.
control it. We want to make sure they're comfortable, provide a good experience, all of that.
Yep.
So,
Yep.
so what other kinds of automation are you seeing coming down the pike?
Oh my, I think of probably one of the things today is integrating not only your HVAC, but your lighting and your blinds and shades. Um, they're it all it's all part of the envelope and part of the energy of the building. But there's there's the new room controllers, and I'm going to call them application specific controllers, but it's at the high school. Every one of the boxes has a VA, every one of the rooms has a VAV box on it. So
Right.
that controller on that box is up there doing the HVAC stuff all day long. Now they're adding the ability to do the lighting control and any shades and blinds and that kind of stuff. So you step up to the thermostat, press a single button, and the outside blinds would drop down. You could have a projector turn on or a screen drop for it, and it would dim the lights on the projection side of the room and leave them brighter towards the back. There's we call it light harvesting, daylight harvesting. So now you have windows on the south side of a classroom, and you get all that nice light coming in. Well, there's no reason to have the lights on next to the windows at all. And so you
Right.
can measure the light levels in there and dim the lights across the room to keep a consistent light level in there. So I think of the total room automation concept, but that's becoming more and more prevalent. Imagine at a hospital, and the patient can lay in bed and adjust the temperature of their room. They can raise and lower their blinds. They can turn the lights on and off, and they never have to get out of bed or call a nurse or anything to do that. So that's huge in that environment too. So, but
That's interesting.
that I see that automation happening. Buildings are just getting smarter and smarter and smarter. The chillers can talk to the air handlers and vice versa, and now they can all, if an air handler has to come on to handle something after hours, let's say, it then knows that it's got to turn on this associated pump and this chiller and maybe this boiler, and so it's just the idea of things getting smarter
Right.
is the technology today. And then I see a couple other things that are more and more in our industry is data analytics. If a piece of equipment is reaching its life expectancy, if an outside air damper that is not calibrated, or maybe some linkages come loose, then it can look at that, and it knows the outdoor air temp, and it knows the return air temp, and it knows the position of that damper. It can calculate what that temperature should be. And if it's not within a range, it can send an alarm. And it can say, hey, you need to go adjust this linkage. And we've done some code that looks at some old VAV boxes, like over at the high school. You've got a bunch of boxes that were put in there originally, brand new with the building, been great, done a good job. But there's seals on them, there's motors on them, there's mechanical devices that just eventually wear out. Well, now you can go and say, hey, I'm supposed to have 600 CFM going into this classroom. And if my damper's at 100% and my duct static pressure is correct, I can now accurately say something's wrong with this VAV box. And I can send a notification that says, hey, classroom 101 needs to have the VAV box looked at it. So the smarts getting into things are we're getting more and more memory in things, and so we can, all those codes, that fault protection, data analytics, all help keep a building more efficient. I think of used to be you would write a duct static pressure reset program, and the mechanical engineer would say, hey, maintain the boxes at between 70 and 90% of their position, and if one of them starts to get off, increase your duct static pressure, and if they come back down, decrease your static pressure. That all works great. What happens when that one box out there stays at 100% all the time? Then that just drives up all the rest of the air handler control. The speed comes up, the chilled water valve or the hot water valve opens more. That then feeds back into the chillers and the boilers, and they have to work harder. And so you put things in there to say, hey, if this box is not performing, let's throw it out of the equation on how we control things and send that alarm so somebody will come look at it. That way, if it's 100% open, you're probably never going to get a temperature complaint from that teacher. So
Right.
so they're not going to complain, or you're never going to know that. And
Right.
so you can be more proactive about things today. So
So let's
uh,
talk about these lines of code.
uh
So it seems like, and tell me if I'm wrong, but it seems like there's a lot of tweaking that happens in the code. I don't know,
yeah.
almost continuously.
Oh yeah.
I know some of my friends that are in the industry, they actually have somebody that they call the control guy that
Yep.
I'm assuming is working in the code.
Yep.
Is there, a size of district that makes sense for? Because I have other friends that, outsource that and work in partnership with a vendor that handles that part of it, and they work together. What are you seeing in the industry for that specific of a person to be brought on board that is, they're not working on, they're not out turning wrenches necessarily, but they're increasing the performance of the system and monitoring the performance of the system. So is there a break even point where that makes sense to bring somebody in?
There, there. I'm gonna be ornery here and answer that question.
I expect that.
Typical Steve.
Yeah,
um, so there is a point. Well, first off, the funny answer is asking the control guy that question is like asking the barber if you need a haircut.
there you go. You're always going to need a
Of
haircut.
course,
Yes.
but realistically, there is there are so many things that we do that the control system controls that if not maintained properly can cost you what's your number two expense on your budget.
The energy,
Employees are
probably.
going to be one, energy is
Right.
usually two or three.
Right.
And if we're not constantly staying on top of schedules and operations of equipment, then our energy costs just gradually rise. And as you know, if a bill raises $1,000 this month and $1,000 next month, and we go, oh, it was hot outside, or oh, it was cold outside, we kind of write it off.
Right.
We can explain that. Well, at some point, and especially in a district your size, um, the energy savings associated with somebody that would just pay attention to those controls, tweak and tune anything from the loop statements. A loop statement is a PID loop, proportional, integral, and derivative is what PID stands for.
Okay.
That was tuned at some point based on some characteristics. If that changes a little bit, it needs to be tuned again. It's not an adaptive type thing. It's just straight out. If the temperature changes, my valve percentage changes. Um,
Right.
Add some time to it, and then maybe some thinking so that it's not cycling too much. Um, but I could go to any control system anywhere and constantly tweak and tune from an energy perspective. Um, you do a project and it goes through the commissioning and it's all working and life's great. Um, I guarantee you at the end of that, there are ways to save energy. And
Right.
so a control person on staff can literally pay their wages, or you're going to pay their wages if you don't maintain it. You just don't
Right.
have that body on staff. So kind of a smart aleck way of answering that question. But I would say any large district, multiple buildings, they could definitely have a control person on staff. Now, maybe that control person doesn't do it 100% of the time, um,
Right.
but that's that extra body that helps with snow removal and all the
Right.
other ugly things that happen in the district.
Other duties as assigned is what we like to call them in education.
Yep, there you go. There you go.
Yeah. For just the
Um,
listeners know, so my district, we have 12 schools, nine elementaries, two middle schools, and one high school. And then we have, I don't know, five or six other just ancillary buildings that kitchen, transportation, that kind of thing. So um, I would say we're on the larger side of the school districts for sure.
Oh
Um,
yeah, no, totally.
what about guys that, through the years have, this building has this control manufacturer and this building has this control manufacturer. We've been fortunate to have some significant bond issues recently where we've fairly well standardized. It's not a perfect world, but we at least seem to have one main system. But what about districts that have, I don't know, three, four,
Yep,
five different manufacturers, and
yep.
are they logging into different software for either one of all of those different systems, or is there something that can pull it all together?
So back in the old days when everybody had proprietary controls, whether it was a Honeywell system or a Siemens system or a JCI or whoever, that they were proprietary. So they were never even built or intended, and maybe it was intended not to ever talk to anybody else. So those would be separate, totally separate systems, and you would log into different computers or web GUIs or whatever to control that stuff. So you end up learning, two, three, four, five different systems, and and they can all be slightly different in
Right,
how you do things. Um, Everybody has some form of a PID loop statement. Um,
right,
I think of today, everything's gone to the BACnet standard. ASHRAE developed BACnet with all the control vendors, a number of years ago, just to address the frustration of why won't my Honeywell system talk to my Siemens system? And
right,
it seems so simple. and
right.
yes, yes, from a facility perspective, like when I was a facility manager, yes, totally. Um, Now in the BACnet world today, we can most everybody is putting BACnet on their chillers, their boilers, their some controllers, and so you can pull things into different systems now. Um,
Okay,
when you do that, um, there are you're still sitting there with you've got, let's say a chiller's got a BACnet card in it. You're limited to what that chiller can do, you know.
right,
And I would never advocate putting our controls 100% on and control a chiller, because these new chillers with magnetic bearings and things, the manufacturer is going to do that the best. There's none of us are going
right,
to do that better. Um, but if you do that, let's say on a rooftop unit, um, now all of a sudden you pull it into your control system and you want to do something with it or make a change, you're still limited to what that manufacturer built into that rooftop to do. And so now if you repurpose that room or that area that is controlled there, you may need to change some stuff, how that may control a little bit. So
right.
BACnet has made this easier, but there are still limitations with it. It's not 100% open thing, where you have access to all of the sequencing that's built into a rooftop unit.
Right.
So so it yeah.
Okay.
That that's a fun
Complex.
question. That's fun right there.
Yeah. Yeah.
Um,
Yeah. It goes back to my first statement. I had no idea how complex this was when I was just an architect. Now that I'm in charge of 15 plus buildings, it's a totally different discussion, that we have. So
yep.
anything that and we've talked about a lot of stuff. Is there anything that you want to highlight that we didn't hit on?
I am, I think the future is very much going to be computerized, going cloud-based now. Um, I think that we're going to have a mad dash to putting everything in the cloud. So security, internet security is getting more and more predominant in everything we do. Yeah. Uh, it wasn't that long ago that dual authentication was the newest thing.
Right.
I now have apps that have triple authentication, and it has to be on that specific device. It can't be transparent from my phone to my computer. Imagine a control system that now the field panels, the main control panels, they reside on the network. Okay. And they, to communicate, to share information, are going to have to do some form of authentication to be on the network. Um, there, there's you have your district computer and it's considered safe. You get to walk in every morning and plug it in and it hooks up to the network. We're coming down to a path where that's going to be seen as a third party device and it's going to be a zero trust network. So
Right.
I see our industry with a lot of that stuff coming at it.
Well, it seemed like I don't remember the details, but wasn't there a giant breach at Target and they entered through the
Yeah.
HVAC controller
And that was probably 10,
a year?
12 years ago.
Yeah.
Yeah, no, totally that. And, um, and passwords are important. None of us like to change our passwords. And holy cow, trying to remember something that's got all these different characters and
Right.
capitalizations. And yeah, that's a big deal. That is a big deal. We have customers that that they don't even allow us remote access from security perspective. Um,
Right.
they if you're not an employee of that facility, you are not going to get online from any
Right.
place. So, and
You almost don't
I
want to talk about security because when you talk about security, then people find out and then like they're trying to hack you. So,
yeah, oh yeah, it's crazy. So
but it
yeah,
is
there's
interesting to think about as these devices become more integrated in the network, they have to maintain a certain level of security, just like everything else. So,
yep,
interesting discussion.
yep, yeah.
Okay, so I think we've covered controls really well, at least at a baseline. So now I do this with every one of the guests. It's this rapid fire.
Uh-huh.
So, what would your parents say you do for a living?
Oh my goodness. Um, I they have no idea. Um, but my mom, who is 80, upper 80s, she goes, my son put that thermostat in.
There you go.
And that's
Hey,
all she would know.
that's perfect. So, do you like using paper or digital for notes and planning and that kind of thing?
I am all about the digital world. Um, the the paper things I used to do, like if I'd quote something to a customer, man, it was all handwritten, and I had my notes, and I went to school to be a draftsman. So when I'm trying, I can write real neat, and oh man, it looks great. Um, but no, the digital is that
Absolutely.
now. The downside to that is if you get a good virus, oh my goodness, there goes all your information. So,
Yeah, that's
but
exactly right.
but I don't need a great big file cabinet sitting in my basement or my office
No,
anymore. But I'm
no.
used to all of that. So yeah, digital.
Okay. So, when do you do your best work? Are you a morning guy, afternoon guy, night guy? When do you get your
Oh
best
my,
work done?
um, I so I am a workaholic. And so I'm in 12-step program right now for that.
There you go.
I'm just kidding, but no, I love to work. So I'll answer that in the early in the mornings, 6 to 8 o'clock. I can get in and get a couple of things done without the hustle bustle of the phone and some interactions. Um, and then I'm 90% of the time I'm in the office from 5 to probably 7. The
Okay.
wife likes to have me home by 7. And so when do I get my best work done? It's at the beginning and the end of each day, because the middle of it gets filled up with all the rest of the stuff going on.
Yep.
Mm.
Yeah, for sure. I've noticed here I get in about 7:30 and everybody's in buildings at that time. So it's busy all day till about 3:30 and then it's like it just goes radio silent. Like the phones
Yeah.
quit ringing. Um, it- Everybody's going home for the day and I can get a good hour and a half of solid thinking in right then. So,
Yep. Nope. I'm the exact same way.
Well, Steve, thanks so much for joining us today and talking about controls, a very important subject that all of us have to deal with every day. How can people get a hold of you if they want to get some more information or talk to you about some issues they're having?
Oh, they feel free to reach out either email or phone. They're 316-250-8129. I am on LinkedIn. You can do that and message things there. Text, email, call me. I'm good either with any of those mediums. So yeah,
Sounds
feel
good.
free.
So it's Steve Mankins at BCS, which is that short for Building
Uh,
Control Systems?
Building controls and services. Yep.
Okay. So, well, thank you very much for being on. Greatly appreciate your time, man.
No, thank you. Thanks for the opportunity. I really enjoyed it.
Thanks.